Agentic AI, computers using computers, and all the news stories around that. What does it all mean? What does closing the loop mean? We're gonna build it, at least baby's first version of that. It's a party of mini PCs over here. This is our MSI Cubi Nuc running Windows, perfectly ordinary there. But I've got it hooked up to an agent, and it's all running locally. But the AI is not running on the Cubi Nuc. The AI is actually running on DGX Spark, our MSI EdgeXpert, to be precise. And it is marionetting our MSI Cubi Nuc. It's part of a triumvirate of technologies that allow you to close the loop, as it were. The loop is, here's the thing I would like for you to do. Here is the success criteria for knowing that you've done it. You build that algorithmically, and then you've got an agent running and doing things. And there it is, our Pac-Man clone in the browser. This was with the Hermes agent, but I'm also going to show you a full setup with Turnstone. Basically, you set up the AI, and then you hook the AI up to the harness. And Turnstone and Hermes do some different things. OpenClaw is also really popular, but I'm not going to get into OpenClaw in this video. But let's talk more about it. Okay, bottom line up front, there's a full guide on the Level 1 Tech's forum that'll walk you through all the steps to set this up. If you just unpacked your DGX Spark and you got a mini PC laying around, you can follow the guide and set everything up on the mini PC and everything is great. But if you're here to learn about like all the buzzwords and everything that's been, all the people are saying about agentic AI and closing the learning loop and that kind of thing, let's calm down, take a deep breath. It is a little bit of a hype cycle, I think. Let's start at the beginning. The things that are in play here. One, DGX Spark, or MSI EdgeXpert. This is where the AI is running. It's all local. It doesn't have to be local. You can run it in the cloud and do that kind of thing. You're probably familiar with chatbots. You chat with a chatbot. It tells you to do things. Maybe you copy paste commands and then you get errors and you paste it back. Then the next thing that happened after that was a harness. And the first harness that sort of took over the world was OpenClaw. And it's very Wild West, very loose. That's the one where we sort of all make fun of it because it's like, oops, it deleted all your emails. Not good. There's also Hermes, which I think is much more mature and adult-like. And then there's Turnstone. Turnstone. It's something that like is amazing and you should check out, and it's on GitHub. It's from Patrick, and I've done a little bit of work on it too. Like I added some interface stuff to it for Nemotron, the Nemotron Omni model, so that it could do voice and video. And so I've also been working on Turnstone this whole time. So Turnstone is a harness to harness the models that you can chat with and hopefully turn their productivity, turn them towards something productivity. Turnstone, also sort of funny because Turnstone makes fun of like the claw thing. Yeah, anyway. And Turnstone is a harness that we can use. Now the harness gives us some other things. It gives us a lot of other things. It gives us a way to not just have one chatbot, but to run a bunch of sessions on a model simultaneously so that we have a bunch of instances, chat instances working together to accomplish a goal. Those are called agents. When you're using AI like that, the AI chat things, the agents work together. And so Turnstone can be said to be an orchestrator. It's like an orchestra conductor. It's conducting a lot of AI agents. This is why there's been a token explosion. It's like first it was chatbots, and then it was reasoning chatbots, and that was the first token explosion. And then there was another token explosion. There have been several. When we talk about you as an individual are not just talking to one chatbot at a time, you're talking to kind of a supervisor chatbot, and it does other things. So if you look at Turnstone, you look at the orchestrator, the setup here, there's a drop-down menu that lets you configure what role is this going to play? Orchestrator, engineer, maybe scribe for documentation. This is sort of useful for the role that the AI is going to play. Now, I know what you're thinking. AI is not deterministic. It doesn't behave consistently any which way. It is not good to give it access to this, that, or the other. Yes, totally agree with you. But there are ways of mitigating that, and there are ways that you use AI to build durable infrastructure with a harness like this. So instead of building something where you just turn the AI loose and you say, hey AI, babysit this thing, that's not really what we're doing here. It is, hey AI, help me build a durable process that may not even involve AI by the time we're done, but is sort of cooperatively built with, human and AI. And so the process for that is, it's all kind of Wild West. Different people are coming up with different processes. Everybody sort of imagines that their way is the best way. I like Turnstone for its enterprise architecture and how it does output guard and that sort of stuff. I've got a separate video coming on just Turnstone. Turnstone's really exciting. You can check it out on GitHub, but I don't want to get into that too much in this video. But it does have a lot of safeties and guardrails and enterprise architecture, enterprise think that Patrick and I have put into thinking about these kinds of problems and how it might exist in an enterprise and how you might give it access to help you configure switches or manage servers or help you manage software. See, even these really advanced AIs, I mean, they have the skill, they don't have the taste. And that does, you know, some people, it's like, oh, the goalpost is moving there a little bit. But when you're doing really big enterprise architecture, you're going to have to step in and get your hands dirty. You can't just say, hey, go do this thing. And the harness is useful for that and spinning off the agent, that sort of stuff. So there's also a judge. There's a judge model that's judging what's happening to make sure nothing is going off the rails. And in our case, we're using Gemma for that from Google. So we're running Nemotron to do the heavy lifting here that I'm showing you in this video, but we're also running Gemma at the same time. And Gemma is kind of watching what Nemotron is doing. That gives us some resiliency, that gives us some insight, that also gives us a place to pump the brakes. And this system also has permissions. It's like, this is a high risk thing, this is a low risk thing, this is a safe operation to do. The harness has this idea of skills that explain to the AI how to maybe call a script or to do a particular thing. That can be read into the context as it is relevant to understand what it was. Think of it like a quick manual. So like I don't know, you have a piece of office equipment in your office, like maybe the coffee machine. It's like the coffee machine requires you to first put in the coffee cup and then turn the dial to whatever mode that it's in because it resets every time. And then you decide if you want hot or ice, and then you press the button. So a skill file would explain that to somebody, like how to operate the coffee machine. It's really not a lot different. Sometimes there can be Python files bundled with skills. Then there's this idea of MCP, Model Context Protocol. There's lots of MCP servers out there. If you do home labbing and you do stuff with Proxmox, there's a Proxmox MCP skill. That's a whole other story. There's some fun stuff coming with that. But the Proxmox MCP skill explains to an AI the kinds of things you can do with Proxmox, like how to create a container, how to create a VM, how to move storage, that sort of stuff. But the MCP exposes those skills as part of the MCP server because the skills aren't really relevant if you don't have the interface to call it. And the MCP can have different transports. So like you can do standard I/O, STD I/O, that is for local host stuff where everything's running on a single machine. And then there's also an HTTP transport, which is what we'll be using this video to control that Windows machine. There's lots of different MCP servers for different use cases, in other words. So the MCP server that we're going to be using on Windows is called Cursor. And it's pretty good. It's a little clunky, but this, again, crawl, walk, run, I think it's a lot of fun to show you what the possibilities are. And then maybe you get some ideas for fun stuff that you can do. The stuff that I'm showing you, it should not reasonably replace any human being at all. And that it seems to be in corporate America is probably more of a testament to how poorly understood things are with management in a lot of cases. But I digress because, you don't want to offset the multiplication of your productivity by tamping down your productivity because you got too productive. You know what I'm saying? It's sort of weird.
To set up Turnstone. This is going to be another video. There's really a lot to talk about as far as Turnstone goes. There's a lot of really exciting things, but the quick start is pretty good. And the how-to will walk you through that at the terminal. On our totally fresh Spark system here, we basically just run the commands. It's going to clone the GitHub repository. It's going to ask us how many server nodes we want. I've chosen 6 because we're going to be in a relatively memory-constrained configuration. This is basically how many workers you have that are running here. This is all managed through Docker. When you run Docker PS, it's going to show you these containers. It'll run through, build the container, and it'll tell you all the stuff that it's doing to set this up here. If you want to customize this, you can modify your Docker Compose YAML. Then the setup helper will emit this, and you're good to go. Now, we went through the, earlier in the how-to when we're talking about setting up the VLLM images and that sort of stuff. You can go through the DGX Spark playbook and get there. But there is also a helper, an alternate way is what it is described as in the how-to. It's VLLM plus light LLM on one unified memory box. And what this is going to do is give you reasoning, perception, and re-ranking. Re-ranking is important here. Now, I haven't mentioned re-ranking before, but it sort of goes without saying that garbage in, garbage out. And that's true of anything in computer science, especially AI. And so what re-ranking does is it improves the quality of the information sent to the LLM by sorting retrieved documents based on how well they actually answer the user's questions, rather than relying on embedding similarity. This means that the model retrieves more relevant context and spends fewer of its limited context tokens on unrelated lower value information. So as the context grows, we're working with local LLMs here. It's tough to do a million token context. It is doable, but you're gonna need more than one Spark, and or other systems that are have larger memory. And so the re-ranker helps keep the quality of the output really high because it is re-ranking the things that are fed into the model with things that are relevant. It's sort of preloading all the relevant stuff. It's a time saver and a token saver. So it's pretty awesome. And having the re-ranker run locally, even if you're feeding a cloud AI, is huge. So these how-tos will walk you through that. Stay tuned for the full Turnstone video. But I feel like this is a really easy installation. Patrick has done an amazing job with this write-up and all of the stuff that has gone into making the installation of Turnstone as easy as possible. If you stumble over something or you have feedback, definitely let us know. But early community feedback from early adopters has been pretty positive. Now from here, making sure Turnstone is running, we can do Docker PS. We can see that all this is running. We see our 2 LLMs are running, 3 LLMs are running. Well, this is the, yeah. So we're up a few hours because, time passes. And so this line here tells us that the web browser part of it is running and it's on port 443. You could change that if you have other stuff running. 8443 is what I use sometimes, but that's just in the Docker compose file. But this means it should be accessible on the browser. You can get to it from the console on the DGX Spark or from another machine on your LAN. When you go there, you'll get a privacy error. It's fine. We'll just continue. It'll ask you to set a username and password. I already set mine. And then here we go. So this is the Turnstone UI. And again, I'll do a different video on this. This is just a fun harness. This could be Hermes or OpenClaw. Although, start with Hermes. Like OpenClaw, OpenClaw is just too Wild West. Hermes is pretty good. Hermes is actually amazing, but it's a different thing. Solves a different set of problems. It's not solving the exact same set of problems that Turnstone does. All right, so the first thing that we'll need to do is go to Models and hit Add Model. And when we add a model here, we want to give it an alias. But first thing that we'll do is just give it a base URL, and the API key can just be test. And then we can do detect down here at the bottom, and it says, oh, one model available, 65,000 tokens. And we can come up here and the model ID will autocomplete and the alias will autocomplete. Now, if you were following along, mine already autocompleted, but it's because I had to do this a second time because my context is a little low. The judge model on Turnstone needs kind of a lot of context, 65,000 tokens. If you set this up the alternate way, it'll be 131,000 tokens because the alternate way is a little more efficient because it's using VLLM and light LLM at the same time as opposed to multiple instances of VLLM. 128 gigs is not enough memory. It's like, this is learning. This is actually really good stuff for you to learn how this stuff is put together at a larger scale. You also have options here for capabilities, tools, vision, server-side web search, reasoning and effort control, speech-to-text, transcription, text-to-speech and speech-to-text, audio input, and re-ranker capabilities. And so setting these appropriately for the model is important, but for this thing, I'm just going to skip over it for now. We'll also want to do add to model for any other models that you have running, get 2 or 3 of those configured in here, and then you'll want to hit sync to nodes so that it will sync to all of these nodes and they're aware that they have a model there. With the models created, we'll just do a quick smoke test here. Options, we don't need to set a persona, and we want it to run with Nemotron 3 Nano. Could use Nemotron 3 Nano or Gamma 4 as the judge. You can assign it to a project. And this is the first time this model has been used. It just started up. If you want to, you could do Docker logs from the terminal and see what it's doing. There we go, about 45 tokens per second on Nemotron 3 Nano. And this can vary. If you do the alternate way, I have seen setups on the forum that are up to 27 tokens per second, but VLLM right now, NVFP4 and like dense models, the real limitation there is memory bandwidth. And so this is doing a little bit of a smoke test on all 6 nodes. And so it'll dispatch things to all 6 nodes. You'll see it over here on the side. There is a light and dark mode. Like I can toggle between light and dark mode while we wait. Isn't that exciting? Fun times with Turnstone. Now that this is set up, we can set up our MCP integration. Extensions, skills, and MCP server. So I mentioned skills and how skills work. You can create a skill, and it's like you describe what the skill is here. There's tons of skills on GitHub. You can go find skills and paste them. You can set options for the skill, how much thinking or reasoning it needs, a runtime config, which model works best with the skill. You can also say what tools are allowed in the list of tools that are in the system. In resources, you can also add scripts. So if you have a Python script or a Bash script or something like that that is part of this tool call, you can add this. And this is where I've added some of my scripts for doing certain kinds of tasks. So I can ask the AI assistants like, hey, can you prep this system by running this script? That way the AI is not YOLOing a list of tasks. It is looking at this skill and it is saying, okay, here's the stuff that I'm supposed to run. And then in the skill, I say, you know that this has succeeded when you run this and verify, like you run the package manager and verify that all the packages have been installed or whatever it is. And the nice thing about this versus a traditional script is that it's a little less brittle. So like, you know, installing a bunch of packages with apt is super easy to script. You don't need AI for that. But when Canonical does crazy stuff like changes the core utils to Rust and that sort of thing, and things break in strange and subtle ways, this thing can actually troubleshoot that and deal with that. Like the AI can do that, and then it can flag it and say, hey, we might need to adjust the skill, or hey, we might need to adjust the scripts as a junior intern level assistant might. But that's not why we're here today. We're here to do the MCP interface to our little Cubi Nuc AI Plus, and we need to add it here, but first we have to set it up on the Windows machine. And now the Turnstone is complete. We can take a look here. All 6 worker nodes are reachable and ready for work. The cluster nodes spawn a dedicated worker on each, all 6 work streams. If you want, I can send the report node ID and timestamp, get an actual response. Just let me know what would be fun next step. Let's see, do that. And look, we're only using 14 of our 262,000 token context. Approve, deny, approve all. You can go ahead and approve. And then we'll see these nodes come online. That's what the icons mean. If we need a little more insight into what a node is doing, we can click on that, of course. So once I hit approve in the corner there, it will create children that is doing the smoke test on all 6 nodes just to make sure that they're there. You can also deny, you can also have a conversation with the model to say, hey, don't do that. There's actually kind of an extensive thing in Turnstone. Again, this is probably going to go in the Turnstone video, but under governance, under personas, you have some different roles that it can play, you know, manager role, engineer role. This kind of thing does actually help. In the judge section, there's a lot of options for output guard, heuristic rules, and how these kinds of things work. And so the output guard is heuristic. It's not necessarily AI based, but AI is using these tools to achieve an outcome, and that is much more effective than just stuffing it all into a prompt.
So on our little Spark system, we're running, right now we're running Nemotron models. There's Nemotron 3 Omni, which is designed for, transcripts, like video, understanding video and audio and pictures and multimedia. And it's also capable of reasoning. It's what's called a 30 billion parameter model, but we're using it in NVFP4. But there's other stuff running on our Spark too. We also have Gemma 4. That's from Google. That's not from NVIDIA. We're using that as a judge model, and it's a very small model. We're using the 4 billion parameter version. There's also Gemma 3. The 12 billion parameter version of Gemma 3 is also a pretty good choice for a judge model for our harness. And then we also have Nemotron 3 Nano, which is also a 30 billion parameter model, but is a little better at other things. Now, it's Nemotron and Google, but then there's also Qwen. Qwen, a lot of people like Qwen 3.6. Qwen 3.6 is available in 2 different formats in NVFP4, and that is the 27 billion parameter model. That's called a dense model, which means that all 27 billion parameters are active at once. That runs a little slower on our Spark system, or Qwen 3.6 35 billion, which is 3 billion parameters active at once. That's what the A3B means in the name. And that's going to be much faster on the Spark because there's only 3 billion parameters active at once. Now, the 27 billion parameter model in an 8-bit quant, which means it's going to use 27 to 32 gigabytes of your 128 gigs of memory, that is probably the best agentic coding model for coding. The Nemotron models aren't bad. Of course, an enterprise model like from OpenAI or Anthropic, those are going to be even better. And you can mix and match those with Turnstone. But the important thing of running 3 different models on this is that with the appropriate harness, you can control a whole fleet of little AIs that are good at the various things that they're good at, but all of them are running on one piece of hardware. Or if you have 2 Sparks, you can have some models running on one Spark, some models running on the other one. You can even run really large models across multiple Sparks. That's what the ConnectX-4 interface is for. But generally, those run a little slower, and it's not really as useful. With the Agentic harness, though, you can run small models to help you plan or to help you do janitorial tasks, if you're doing coding tasks, things like cleanup, managing the Git repository, looking for common things. And that'll also help you minimize your cloud token spend, so that's really efficient. For this video, we want to also talk about skills, which is part of the harness. The harness can say, hey, here's a list of skills, and skills are descriptions of how to do things that the AI models can read and understand. And keep in mind that everything that I'm showing you is running entirely locally. We're doing the AI off of the Spark machine, but the Spark machine is basically marionetting that MSI Cubi Nuc PC. And skills give it some hints about how it does that. The MCP server also will typically publish some skills. And the Cursor MCP server that's on GitHub, I think has 18 or 19 built-in skills, things like opening files, manipulating the registry, common things that you would want to do on a Windows machine. So that's pretty awesome. IMHO. Let's take a closer look at what that looks like on the Windows side of things for MCP and how that interfaces with our harness. So this is our Windows workstation. I know chaos abounds. I can't help it. This is our MSI Cubi Nuc AI Plus that I reviewed previously. And it's connected and it's a little pile of wires, but it's running Windows over here. And it's running our Windows MCP client. This is just a Python program. So you'll need to install Python before you use this. And then to connect this, you'll just run Python muvtool run MCP serve. The full guide for this is on the forum. And I'm using it with an auth key, but you can use it with a TLS certificate or something like that. What this does is it opens up a port, it's port 8000 on this machine, which will receive authenticated connections, ideally with TLS. In Turnstone, under Manage, under MCP servers, we need to set up the connection to this MCP server. The transport is going to be streamable HTTP, and then I'm going to give it the IP address of our Cubi Nuc, 8000/MCP, and then authorization with the bearer. You have to set that in the header manually. Just follow the how-to. Multi-tenant authorization, we're just going to use a static header for this. Auto-approve tools and enabled. And so when you save this, and now what this is going to do is expose this MCP server to Turnstone, the agents and the orchestrator that are running here. And this Windows MCP server provides some tools, some basic tools, and a description of how to use them. And so I can come now to the dashboard or the orchestrator, and I can say, please launch Notepad. And again, like this is kind of a crawl, walk, run example. And Notepad is launched. And Notepad launched again. And so I told it to say hello from Turnstone, but it messed up a little bit. It took a screenshot, saw that it messed up, and then said hello from Turnstone. Can you tell me anything about this machine, CPU, GPU, Windows version, and any other relevant info? And so this will run a PowerShell command, inventory the system, look at device manager, Intel Panther Lake, XE3. So here's our full system overview. MSI Pro PTLH Cubi Nuc AI Plus, that's the MSB211. I didn't even know that. Windows 11 Pro 25H2, installed March 9th, 2026. 16 cores, 16 threads, base clock 2.1 gigahertz. Integrated XE3 graphics. 2 gigs of shared VRAM. Display is currently 3840 by 2160 at 60 hertz. It's the integrated XE3 iGPU with 32 gigs of total memory. 1 terabyte Phison ESR 01 TB TCCZ, and it is dual channel DDR5 5600. And we also, it's like, oh, by the way, a little while ago, we just ran the AIDA64 memory and benchmark run, and these numbers are, in line with memory bandwidth. Now, remember, all of this is running locally. This is taking a screenshot and doing stuff with the screenshot, but it's entirely locally. I mean, it's executing code on our Cubi Nuc, but the screenshots run over the network to the MSI EdgeXpert DGX Spark. None of this hits the cloud. This is toward the kind of experience Microsoft promised with Copilot, except this is something that I'm much more comfortable-ish running locally, because none of this ever hits the cloud. I mean, the AI can just take a snapshot and do stuff with the system. Now, I wouldn't, because the AI has full access to this system, I wouldn't put any privileged information on this, even though Turnstone has a lot of guardrails and safeties and that sort of thing. It's really quite innovative in that respect. I am HO, but again, wait for the video on Turnstone for more about that. But again, it's compartmentalization that's access. It's like this is the AI intern. Would you give the AI intern full access to literally everything? No. But does that mean that it's not productive or you can't be productive with it? Also, no. I think there is something here. There is something really interesting here, in the way that that some people were making fun of home computers when powerful computers, mainframe computers, were the only computers on Earth. It's like, why would anybody want a computer at home? They're inferior. They're not very powerful. You can't really do much with them. And yet enthusiasts took them and ran with the idea of home computing. This is sort of the same thing. We're waiting on the technology to catch up a little bit, and or the hype for the technology is driving some of the complexity and expenses here. But this is really kind of fun and interesting that I can marionette this Windows machine from another computer, an AI interface. Now, the Windows MCP GitHub, it talks about interfacing with like Claude Desktop and services like that, but that means that it's taking a screenshot and doing things with cloud APIs, which I don't know that I would necessarily recommend. This is all running totally locally, which is fantastic. If you'd like to set up Hermes, the Hermes agent, instead of Turnstone, it's pretty much the same steps. You just set up the AI models, you get the models running on your DGX Spark. It's still a good idea to run multiple models for the judge and that kind of thing, but Hermes doesn't really require it. And the out-of-the-box setup with Hermes, just the very most basic setup, is you run the installation from PowerShell. It's paste a command, basically. You let it run. And then the Hermes setup wizard wants you to use their cloud thing. They want to make it as easy as possible, but we don't want to use the cloud thing at all. So you just sort of let that run, go through the setup, and then you'll have to run Hermes setup again. And then when you run the Hermes setup again, you'll choose option 32. And when you do option 32, you'll enter the IP address of the DGX Spark, of our MSI EdgeXpert, and then you can let it auto probe for available models. Now, in the office here, we've also got a 2-Spark setup, running a special NVFP4 version of DeepSeek, which is, crazy, I know. But if you're using Nemotron Ultra or Nemotron 3 Nano or something like that, it'll auto-detect. It makes it pretty easy. And then when that's set up, you can just run Hermes. If you're not sure which model it is, or you just want to, do a quick verification, you can do that in Firefox. You can just go to http:// and then the IP address of your machine, :8000/v1/models. And it'll tell you which models are available. Remember, we got port 8000, 8001, 8002 for different models that are running on the system, all the way up to 8003 and 4 for the different instances of VLLM. And if you wanted to use Turnstone's light LLM setup, but actually use Hermes as the agent, you can do that too. That's fine. I'm Hermes agent running on your local machine, ready to help with whatever you need. So this verifies that it's working. Now, Hermes solves a different set of problems than Turnstone does. The other thing with these agents is that they create notes and memories by just writing to markdown files. Turnstone has its own facility for storing memories. Metacognition is what we call it, but in Hermes' case, you can have it learn and take over. That's what it's like note-taking, productivity, research. It's a whole rabbit hole. You're getting ready to go down here with agents. And you close the loop in the same kind of a way. It's like, here's the evaluation criteria. Here's what you look like. Run the thing, do it. Hermes computer use install. It's like, oh, I need I need the skill to use the computer. There's Notepad, it launched, it's not the active window. Gonna take a screenshot to verify it landed. Open in the background without stealing focus from your current work. Nice. And it did type into, hello, this is Hermes agent, but it was into the config YAML that I already opened. Woo! Agents are gonna take over. It's like, this is why it's like, oh, layoffs because of AI. Sure, it's not layoffs because of economic downturn. Okay, so what's the loop? Like, you've probably seen or heard the agentic loop, or like, now I'm not talking about human in the loop, although human in the loop is a natural consequence of this. But with a skill, you can set, this is the steps to accomplish X, but you can also put evaluation criteria. Here is the criteria that you run to evaluate whether or not you've been successful. And the loop is the AI will run and do the thing and then see how complete it is or how much progress it made. And there's different kinds of loops. Like you could do a hill climbing loop where the AI will iterate toward success. Like it might not be able to get to success immediately, but you can give it evaluation criteria to say, oh, this is more successful, this is less successful, and then let it run and do things. Now, for the demo that I've showed, it's a little contrived and not super effective, and you would probably mock it if I said, hey, let's use this for an actual business use case. But as a building block, you probably have some creative ideas, and you could probably put something together. Other very talented technical people have used this kind of loop system. This is sort of like, here's the goal, do the thing, with enterprise models to do everything from building a hardware interface to an e-ink display. That's right, hooking up a model to a serial port to a physical e-ink display, and then giving it a webcam to where it can see. In the same way that our MCP server can see the desktop of our Windows machine, the model was able to see the e-ink display and help develop a library for controlling the e-ink display completely autonomously. So the AI could do some steps, look at it, evaluate, do some more steps, look at it, evaluate, and go on from there. And that's why the harness can be so important, because our context here is only 256,000 tokens. It's going to be important for the harness to compact the context, and it's going to be important for the model to maintain focus and be able to not lose the plot of the problem that it's trying to solve. And that's a little bit model, and that's a little bit harness. Depending on, again, like I say, if you're doing coding tasks, you definitely want to explore the Quen parts of the how-to as opposed to the Nemotron parts, but it just depends on what you're doing. Nemotron's good all-rounder models for doing things. And don't forget, you can also hook up cloud. Like if you want to do Open Router and send requests to the cloud there that are complicated and bring them back, you can, but running all of this AI locally on your Spark will still save you tokens. So you're going to be spending way less tokens than if the whole thing was hooked up to the cloud. And that can be one of the directives. You can tell the orchestrators, like, hey, I want to send as little tokens as possible. And so it'll spin off an agent that has access to whatever the cloud model is that you tell it. But then that model will be used conservatively by the orchestrator whenever the orchestrator feels like maybe one of the agents is looping or one of the agents has lost the plot of the problem that it's trying to solve. So you have different models working with slightly different goals and slightly different configurations. And that's pretty much all there is to it. There's a lot of promise here. This technology really, it's like the first, sort of meme. I know I always refer to it, but the first meme of Will Smith eating spaghetti, that's sort of where we are with this technology for what runs locally, even on relatively expensive hardware. It's pretty early, it's pretty nascent. But look how quickly we went from Will Smith eating spaghetti badly to nano banana. That's how quickly this technology is moving otherwise, not just with local AI because of sovereign reasons, but also in the cloud and with different cloud providers. And so it's sort of an interesting time to be alive. But you can experiment with all these technologies right now. Like it's all the same at the enormous multi-million-dollar scale as it is in the multi-kilobuck, 10, 20, 50 kilobuck range that you have here. And yes, it is expensive for the individual to experiment with this level of hardware for now, but I think that very quickly it's not going to be as expensive because the technology is going to ramp up, and also we're going to have a better understanding of how to use the technology efficiently. Because right now, basically everybody's throwing everything they have at the technology, and some of it is going to work, but a lot of it, I don't know. It's interesting. Oh yeah, and there's another aspect of this, which is DGX Spark has been out for a while now, but the software has improved dramatically. These mixture of experts models that are running on DGX Spark are dramatically faster than they were at launch time. And some of this is because multi-token prediction. Some of this is because we're better able to access the hardware more efficiently. A lot of it is because of NVFP4. NVFP4 is the star of the show. If you get a model that can natively do NVFP4 and has all of the other features that you need for this platform to like fully take advantage of all the hardware and the relatively limited memory bandwidth, then you can get some pretty amazing speeds. That 35 billion parameter Qwen 3.6 model, you can get upwards of 70 tokens per second with all of the stops pulled out to be able to run it in that 4-bit format. The dense format of Qwen 3.6, the 27B, is more like 15, 20 tokens per second max, using MTP and all of the features that you possibly can in that NVFP4 format. But this is kind of where we are. This is kind of how I see it with Agentic AI and harnesses and that sort of stuff. So if you want to learn more about Turnstone, hit us up in the forum. Let me know what questions you have that'll help shape the video on Turnstone. I'm with level 1. This has been actually a lot of fun, sort of cautiously optimistic about the new technology. I'm signing out, and you can find me in the level 1 forums.